So we have an investigation here about things that you can and can't do with radicals. When you're adding or subtracting radicals, it is okay to add them as long as the radicals match. In this case we have root 2, as in 1 root 2 plus 5 more root 2's. You can think of that as one thing plus 5 more things makes 6 things, 6 root 2's. So adding like that is no problem. Here we have cube roots, and it works the same way. You have 4 of the cube root of 5. You lose 7 of the cube root of 5, so now you have negative 3 of the cube root of 5. All of these use the square root of 8, so same idea. You have 5 of them, you lose 2, so you're down to 3. Then you gain 7, so you're up to 10 of the square root of 8. Nothing happens to the radicand, you just carry it along, and it's the coefficients that you really work with. Number 4 does not work because the radicals do not match. This is a square root, this is a cube root. They are totally incompatible. There's no way you can do this unless you pull out a calculator and just turn them both into decimal form. And here in number 5, same idea. You can't add the cube root of 3 and the cube root of 2. People always want to. They figure, okay, 3 plus 2 makes 5. No, can't do that. If the radicals are not a perfect match, thou shalt not add. So, to restate, you can add if the radicals, or the rule would be that the radicals must match exactly. That means they match in type. They're both square roots, or they're both cube roots, or whatever, and they match in radicand. This has to be like root 2 and root 2, root 5 and root 5. You can't add a root 3 to a root 2. And if that is satisfied, then what you do is you just add or subtract the coefficients. You do nothing to what's inside the radicals, you just work with the coefficients out front. So, demonstrating that, can we add and subtract this? Square root of 7, square root of 7, square root of 7. Yeah, looks good. And our answer will be a certain number of square roots of 7. How many? Well, we had 8, and then we lost 3. That took us down to 5. Starting from 5, we gained 15. We're up to 20 square roots of 7. Here, 5th root of 10, 5th root of 10, 5th root of 10. Looks good. 18 plus 12 is 30. 30 take away 7 is 23 fifth roots of 10. And last one, square root of x, square root of x. That's okay, and our answer will be square roots of x. We had 5. We lost 4 of them, so we're down to just 1. You could write 1 root x, or you can simply leave it as root x.